Hey everyone, it's the 4th of October, which means it's time for solving the 4th October Leetcode challenge question. Let's get straight to it. The fourth one is remove covered intervals. So let's check it out. Given a list of intervals, remove all intervals that are covered by another interval in the list. So what's their definition of here? It's defined interval AB. So I think this means A is inclusive and B is exclusive. Is covered by interval CD if and only if C is less than or equal to A. Okay, so C is less than or equal to A, and B is less than or equal to D. After doing so, return the number of remaining intervals. So they don't care about the intervals in particular, they just want the number. So C is less than or equal to A, and B is less than or equal to D. I need some examples to make it easier for myself. So let's take some numbers that correspond to it. I mean, I guess I have additional constraints. Yeah, there they are. Like this shouldn't be negative, I think. Can they? No. So intervals length is between 1 and 1,000. So this is the length of the intervals. And then intervals I dot length is 2. So every interval consists of only 2 records. I wonder why they keep using lists in these examples. I guess because lists are more general purpose or arrays than data structures, but it would make so much sense for this to be just a list of interval objects, like class that has start and end inside, or structure, let me see, but whatever. Okay, so they are lists with size 2, then 0 less than or equal to intervals I0, and it's less than intervals I1. So the first value is non-negative, and the second value is positive and bigger than the first value. So the second value always bigger. We don't need to sort anything there. And the intervals are unique. I guess this is important. We don't need to do any sort of deduplication like we had yesterday. So let's try to write some example. So A, B, C, D. So if I have the interval 1 and 5, this is my A and my B, and then C needs to be less than or equal to A. Wait, I'm actually gonna make it like 3, 5. So my C is gonna be less than or equal to A, which means I can have a C of 1. And then B, so basically D needs to be larger than B, or B is less than or equal to D. Oh, they can be equal actually. So, but B needs to be less than D. So if D is higher than 5, okay, so this makes sense. If it's anything equal, if it's 5 or 6 or 7, then they're interlapping. If I have a timeline, I have like here 1, 2, 3, 4, 5, 6. This would mean that my first interval is 3 to 5, so it's something like this. This is my first interval. And then my second one would span from 1 to 5. So here it's pretty clear where they're intersecting. It just says return the number of remaining intervals after removing all intervals that are covered by another. But I think like this is a little bit ambiguous. So let's say I have a third interval like 1 to 2. So this is my third interval. Okay. Actually, because I have so many numbers, I'll just call them A, B, and C. So it's easier to keep track for myself. So I have A, B, and C. So let's say I compare C to B. and I decide that I want to remove C because it's inside of B. So in my first like going through the array, I compare C and B. I compare C and B, and I remove C. And then in the second, I compare B and A, and I remove A. So in this case, I would have one interval remaining in the end. But instead of doing that, if I was to compare C and B and remove B, then I have A and I compare C and A and I do not remove anything. So I would have two intervals remaining. Like if the maybe I should read again the task, but if it was about returning the most intervals that can be achieved within the interval array, then I would not have this ambiguity. It would be obvious that I need to return 2 here. But without having this requirement, I actually don't know whether both of these are accepted solutions, or I need like the minimum or the maximum number or anything in between. Oh, there are hints as well. Nice. Let's try without the hints first. So 1, 4, 3, 6. So 1, 4 is not covering 3, 6 anywhere. Then compare 3, 6 with 2, 8. 2, 8 is covering. Here it doesn't matter if we remove 3, 6 or... Oh wait, it does matter if we remove 3, 6 or 2, 8. But wait, 1, 4 is already covered by 3, 6? Oh no, it's not covered because they're like exclusive. So 1, 4, 1, 4, and 3, 6 are actually not covering each other, because 1, 4 would be something like this, since the 4 is exclusive, and then 3, 6 would be like this. And again, the 6 is exclusive, so it actually goes only to 5. So these are not intersecting, but then the last one is like 2 to 8 somewhere. So it's intersecting actually with both of them. Okay, so if it's intersecting with both of them, doesn't this mean that if I remove B here, if I remove 3, 6, then again I'm still having a collision here, because like in the 2 and the 3 are here as well, like 2 and 3 are present in the first interval. So maybe if I just like I start from the first one and then I check them one by one. That doesn't sound like it's enough though. It kind of sounds like for every interval you need to check every other interval. I'm not sure if I can just go one by one, like just compare this to this and then this to this. I just know that the intervals are unique. Maybe I need to sort them by something, like by when they're ending. Let's see more of the examples. So 1, 4 and 3, 2, 3. They're intersecting, so we return 1. 0, 10, 5, 12. What? Why is this 2? They're intersecting. Like 0 to 10 definitely includes 5 to 12. Given a list, remove all intervals that are covered by another interval in the list. Oh wait, covered. Oh my god. I was thinking about this entirely wrong. They're saying it needs to be covered. It's not good enough to intersect. The other interval actually. Yeah, I'm so slow today. Need to get more coffee. So the interval needs to be covered, which means that 2/8, it actually doesn't cover 1/4 because 1/4 spans outside of the 2/8. So here the 1/4, which is actually like 1/3 inclusive, he has this part which is outside of the 2/8, but the 3/6 does not have any part. So this is where the condition that C has to be less than or equal to A, and D has to be larger than B, or like B has to be less than or equal to D, so that they're covered entirely. Okay, I think I finally got it. So let's go solving it now. So I can obviously the easiest solution that would work, that has something like quadratic runtime, would be for every interval check every other interval, and if this interval is covered by or covers another interval, then if it's covered by, I remove it. If it covers, then I remove the other one from this list or array or whatever, and then I return the size of the data structure. This would be my output. But this means that for every input, that can be up to 10,000. Oh, that's probably not the worst, by the way. Oh, no. 10,000 is the number inside. The number are 1,000 here. So 1,000 by 1,000. It's not that many, actually. I mean, that probably is within our constraints. It's okay to do like the naive solution. Is there a better solution though than comparing everything one by one? What can I store about an interval that helps me know whether it's covered or not? So I can have some sort of a heap for both the min and the max numbers. Like I can have a min heap maybe of both numbers, two separate min heaps. So I'm keeping like track of the I keep track of the start, so like the A, and then the reference to the element itself, and then the second one has starts to the B, and then the element itself, and then when I open a when I have an element, so let's say I have those heaps. I'm gonna build them here really quickly. They would look something like 1, 3. They can even be like binary search trees. I'm not sure if I need an entire binary search tree. So they would be like that: 1, 1, 2, 3. After inserting them both, and this is logarithmic time. So this is my start, and then my end would be like 4, 6, 8. So something like that. Now let's say I build those heaps. They both take n time, or maybe I can just take n time once and n space twice. Then I can go from top to bottom. Again, I'm starting with this one. So in order to satisfy the condition, I need a C that is less than or equal to A, and a D that is bigger than the B. I cannot have them separate because those conditions are intertwined. So this probably doesn't work, but let's see what would happen. So I start with 1. I need it to be less than or equal to 1. So I don't have anything. I have a 1 here, and this one points to the element, like the 1, 4. And then it points to the single element 1, 4. I can have multiple ones though, so I need a list. Like I have a mapping here. So I have a 1 pointing to the 1, 4. But it could have been pointing to more elements. And 2 is pointing to 8. And 3 is pointing to 3, 6. And I don't have this. So yeah, I have 1, 4. I can see that it's the exact same element that I'm already on, so I don't care about it. Then I start with a 3, 6, and I check. I start with a 3, and I'm looking for a key here that's less than or equal to 3. I have only a single one, so this key is 3, and it's the same element, so I don't care about it. Then I go to the 2, 8, so I have a 2. The 2 needs to be less than or equal to 8, so I have 2 of them. I have one condition here and one here, where 2 is less than or equal to 2 and 3. Here on the 2 it's not interesting because it's the same. So I need to have a check, since it's never covering itself, but I actually don't need even a specific check because, oh, actually I do need a specific check. But yeah, D needs to be bigger than or equal to B, and C needs to be less than or equal to A. Yeah, so it would cover itself, but I need to not count that. And then here it counts again, and I have the D being an 8, which is bigger than 6, so this one is covered. But did I achieve anything? Like, imagine that every single interval I had the same like start number. Then this would be one single key with a huge list. So having this mapping the way I presented it does not really help me at all. It just spreads this thing here, like the keys that are potentially in a min heap, so that I take logarithmic time to find the key, but that's not good enough. Unless I have like instead of keeping a list, so I have like a binary search tree with these keys, and then for every key that is the starting key, then I have inside of it a binary search tree for the bigger one. So then I would have like a logarithmic time for the first key, and then logarithmic time for the second key. My god, this sounds so complicated when I'm thinking about it like that. I'm not even sure if that's gonna work. Okay. Something else. Let's just clearing my mind, trying to think of something else, some other solution. That's not the naive one, and that's not this one. So how do I know what are the potential, what are the intervals that I'm potentially covering? So one of the ways would have been what I just proposed, but what if instead of heaps I have a hash map, and I have again 2 different hash maps for the start and the end, and then I'm taking no, it won't work as a hash map though, would it? Because then I'm taking every element that satisfies both conditions, and then I'm cross-referencing if they're the same element. So if the element both satisfies the start condition and the end condition, but that doesn't sound right. How else can we store this information? My mind is blanking right now. Holy shit. I wonder. No, them being unique just makes it a little bit simpler, but doesn't really matter in the grand scheme of things. We know that the first element is smaller than the second, which is nice. This information doesn't really help much. This is the condition that we're interested in. I mean, it kind of sounds easier to reason about it when I'm thinking about the size instead of an end index, but it doesn't change the task at all. So like I can say this one has size what, 1, 2, 3, since the 4 is exclusive. So starts at 1 has size 3, starts at 3 has size 2, starts at 2 has size 5. Does having the size help me anywhere? So I can just have a start index and size, and then I can just look at the start index. I mean, it would be basically the same. I'm looking at the start index and I'm saying if the start index is less than or equal to the other start index, and the size is bigger or equal to the other size, then it's covered, unless it's itself. Can I flip it the other way around? So now I was thinking about looking at having some structure and then checking if this is covered by what or is covering. What if I do it the other way around? Would this help at all? Like if this is covered by something else. So I would need like a fast way to get every element that has less than or equal to the first number that I'm currently at. And in order to get that, I would still need some sort of a like binary tree. It doesn't have to be binary, just like a min heap where I can fetch the elements in logarithmic time. I'm so sure that there is like a very optimal solution that everybody knows for this problem, and that just because I'm encountering it for the first time, I probably seem really dumb now, but that's fine. I mean, the whole purpose of these videos is actually that, to show the entire thought process and hopefully have a laugh about it next year when hopefully I'm much better at this kind of stuff, or I don't care about them at all. That would also be fine. I mean, I guess I might as well go with the naive solution if I'm blanking out on everything else. I can check the hints. Is there something about the hints? Compare each interval to others and check if it's covered. I mean, that's what we're gonna be doing anyway. God dang it. There has to be a better way. But, I mean, whatever. Let's just go with the naive one. Maybe I can check in the answers. Like, some smart dude has definitely posted something. So this is the function. And yeah, double checking that my camera is not blocking anything, because I had this in the second video. Okay, so I need to check for every element, every other element. And if it is not covered, I count it. If it is covered, I don't count it. Okay, so for interval in intervals. So this is now the list of 2 elements. This would actually be easier if I had indices like in other languages. In Kotlin it's not as easy. So I need to check all intervals again, but without checking the same one. Maybe it's okay to just check by reference. Then for again interval in intervals, if interval 2, if interval equals interval 2, then don't break, but skip it, continue. Dangerous array comparison. God damn it. Oh, I just need the indices. Can I have like for each indexed? How do I have an index here in Kotlin? Yes, I just do for I in 0 to interval size. Was this range 2 inclusive? Creates a range from this value to the specified other value. And until returns the range from this value, but excluding the specified 2 value. That's what I need. And there is interval indices. Okay, cool. Okay, so whatever, it's just gonna be I and j. Then if I equals j, continue. I don't want to break out of this loop, I just want to make sure I'm not comparing the same item. And then when I'm comparing them, I'm just saying something like var is covered is false, and then I'll just say if and the one I'm looking for, so this is val current is intervals I. So where did my output go? So I'm gonna say if, oh, and actually I wanted this. If a dot if it is covered if a is smaller than c. Wait, smaller? C is smaller. No, a is bigger than c, not equal to. Wait. C is less than or equal to a, which means that a is equal to or bigger than. Okay, so if current 0 is so I'm going to have a second variable here just to make it easier for me to reason about it. So compared is intervals j. So if c is the one I'm comparing, that I'm checking if it's covering. So it means that c, which is compared 0, is less than or equal to a, and then b, which is current one bigger is less than or equal to d, which is compared 1. So if this is true, then I'm just gonna say is covered equals to true, and I can actually break, so I don't need to continue doing this thing. And in the end of this loop, I'm just gonna say answer is 0, and then if it's not covered, then I'll just say answer plus plus. and then return an answer. And check with some inputs. So remove array of this, but instead of having the square brackets, need to say something like int array of, and then this. So I'm saying just this, and then I'm expecting an int, so I can just print it. Let's see. Get the two. Something more tricky. This one looks a little bit more tricky. There has to be like some easier way to do what I'm doing right now, but whatever. This is 2 again. This is supposed to be 1. So 1, 2, 1, 4, 3, 4. I mean, I'm really not proud of this solution, but I'm gonna check if it works. Oh, I guess it's accepted. So this is something I'm struggling with. When should I implement a naive solution, and when should I deep dive into looking for an optimization? So let's check my runtime here. This is O of n, and then n times I'm doing n searches again. So this is the classic definition of n squared, where n is the number of intervals. And considering I have 1,000 intervals, like 1,000 squared is not that much. Like this is definitely something that's computable by modern computers in a pretty fast way, regardless of what test cases they throw at us. But there has to be like a way to improve the runtime. But I guess I would still be paying by quite a bit of memory. So if we are optimizing for memory, in the current solution, we are not using any additional memory. We have like a counter and a boolean or something super free, basically super free. I even don't need this current and compared. I can just say that the current is intervals I0 and this is intervals J0. Can I see discussion somewhere? Let's see how people are optimizing it. Sorting plus popping. Sort. So there is a comparison. He has this thingy in a function, which is nice actually. This can definitely be a function. Remove covered intervals. So he's sorting them based on this. So he's sorting based on the 0th element. And if the 0th element is equal, then he's sorting based on the second element. And then when he sorts them, he says answer 0 and right. He goes once through the list, and then wait, what is int right? Oh, it's a 0 if it's an initialized, probably. So if intervals I1, so this is the first one, the second one is bigger than right, then he says answers plus plus, and then the right is equals to intervals I1. And since they are sorted, are they sorted? Does this even work? Huh, that's cool. Nice solution. Priority queue. So again, like priority queue is basically using priority queue to sort the inputs. And he's calling it a heap. Short and concise. So again, this guy is sorting the intervals and then checking what is the max time so far. If this is bigger, then he gets a new max. And how is this sorted? Again, if the first element is equal, then it's b minus a, which means that if a is bigger, this will be considered less than. So it's sorting by the it will put the second, the bigger element first, like the bigger I mean, if b1 is a 2 and a1 is a 3, then this will be minus 1, which would mean that since he's comparing a first, this means that a would come first, like the bigger one, the one that has a, would go first, since it's considered smaller and it will be sorted in natural order. But this is only if they're equal. If they're not equal, it's just a0 minus b0. Yeah, that's a much nicer solution than mine. I mean, I'm doing quadratic time, and it can definitely be done in n log n time using this sort, and then a single n traversal. Oh, okay. I'm really not proud of this solution that I just did here, but it is what it is. I'm gonna show all of my failures as well. I consider this somewhat of a failure, since I did not come up myself with the solution in n log n time using the sort. It seemed like there can be something done like that, but I couldn't figure it out on my own. So yeah, I guess you can bask in my failure, and hopefully we'll do better tomorrow. Thanks for watching, and see you tomorrow.